and work in an electromagnetic world. Light and heat in moderation are vital to life. Also, an integral part of the modern world is the electromagnetic energy man has added to the natural EM all around us. We are surrounded by electric and magnetic fields, both natural and generated by a wide range of electrical and electronic equipment, such as radio, radar, magnetic imaging, television, and electric power transmission. We benefit from this equipment in many ways. It furnishes us with the tools to earn a living. It is a popular source of entertainment. We use it to diagnose illnesses, and it provides various modes of transportation. But this environment can cause problems as well. Having so many sources and users of electromagnetic energy creates a challenge for us to live safely while operating our systems compatibly within this environment. Electromagnetic interference, or EMI, can be dangerous. In the worst scenarios, EMI prompted disasters. Static discharge in the fuel tank of this helicopter caused this tragedy, EMI related. In this incident aboard the carrier USS Forrestal, 134 men died or were lost. Though the reason for the disaster has never been firmly established, a detailed investigation found that the beam from a radar may have triggered a Zuni rocket on an aircraft on the flight deck. The interference shown blocking this radar scope was traced to coupling from the output of a nearby HF transmitter to the radar's cables. An electric hairdryer, coupling interference over the power line, interferes with this television receiver. These incidents caused by EMI are a result of our high-tech world. Most systems undergo extensive testing so they can be properly integrated into the overall electromagnetic environment. Who is concerned with these problems? A group of over 4,500 professional engineers and technicians work to keep our environment safe from the effects of electromagnetic radiation. Many of them are members of the Electromagnetic Compatibility, or EMC Society, an organization within the framework of the IEEE, the Institute of Electrical and Electronics Engineers. The Electromagnetic Compatibility Society comprises professionals involved in the analysis, design, integration, testing, and modification of systems and devices for radiated and conducted electromagnetic interference. EMC analysts are involved in the early design phases of equipment and systems. They make predictions for performance and compatibility, covering such issues as emission and susceptibility levels and safety of personnel, vehicles, electronic equipment, and ordnance. Engineers participate directly with the hardware and software designers to ensure that electromagnetic compatibility is designed into equipment and systems from the very beginning, such as in proper cable separation and shielding. The integration process is where systems come together. During this process, experienced EMC professionals work as a team to resolve compatibility issues. The EMC engineer can analyze compatibility problems and quickly develop solutions as system integration evolves. EMC engineers and technicians also play an active role in testing equipment and systems. Individual equipment items are subjected to rigorous testing in laboratory environments. The engineers and technicians frequently test the systems in the actual electromagnetic environment in which they will be used. Despite the best efforts during design and integration, compatibility problems will often emerge when the equipment or system is placed in operation. EMC professionals analyze problems, develop solutions, and make corrections. This may range from separating or shielding cables to proposing significant design changes. EMC professionals engage in a wide range of activities that impact all aspects of the life cycle of system development. To gain insight into their jobs and responsibilities, spend some time with 4 EMC professionals: an analyst, a test engineer, a field engineer, and a technician.
The program that we're working on is being done for the Navy, and it is to develop computer-aided design tools that will allow the Navy to better design the top sides of their ships so that various electromagnetic generating and receiving equipments don't interfere with one another. My job is just to develop the computer tools that help predict this before the ship is ever built. We are very dependent on the computer industry in this work. We use massive amounts of computer power to do the things we're doing. The electromagnetics engineer should be consulted or involved in the design process very early on. It's very much a challenge. I'm not near retirement yet, but I'm sure that we could continue to work on this problem for all of the years that I'll be here and not have completely solved all of the problems that are ahead of us. New graduates, I'm sure, would find electromagnetic engineering very challenging. The EMC problems before us are significant, and I think there are plenty of them to be solved, and there's plenty of opportunity for engineers to get involved in that area.
Well, to be an EMI engineer, you really have to have some knowledge of just about every type of piece of equipment that is designed. You have to know about power supplies, you have to know about transceivers, you have to know about computer systems. I like both the teaching and the consulting, and they kind of go hand in hand. When you're teaching, you're trying to get across a structured course to a group of individuals. And I will then teach them, here are the tools that you have. You have shielding, you have filtering, two basic tools. And you have to use them in different ways in order to make your device meet the specification. That's the main problem I probably run into, is having to discuss or having to tell a company that their device is not going to meet the specifications without a serious redesign or a extensive modification. What we see here in our lab is that there is more and more commercial equipment being tested for susceptibility tests. The equipment is getting out in the field or out in the households, and it's failing. They're having problems. So consumers are complaining to the companies. Well, the companies don't want to have these complaints, so they are doing some upfront engineering now and some upfront testing to find out, does their equipment meet a specification?
What we're doing is we're building an automated spectrum management system. The original primary goal of this thing was to be a tool that could be used in a tactical situation. What we're finding, however, is that it has applications certainly to peacetime, and also not to just the military, but to the federal government and to anyone else who needs to use a portion of the spectrum. The FAA, who have to assign radio frequencies in and around airports. Cellular telephones are becoming a big thing and using more and more of the spectrum and are demanding more and more of the spectrum. And as they do that, and as there are more cells, there becomes the need for greater and greater EMC to resolve potential interference problems. So those folks would find application to this. This is not something that is slowing down in any way. There are more and more devices out there that seem to use hunks of the spectrum. So from that point of view, I think the EMC industry is something that's not only going to maintain where it is now, but it's going to grow considerably.
Well, when you work in a lab like this, there is no typical day. Everything's different. Every day is different. You're always testing different equipment, whether it be commercial or industrial or military. We have customers that come into the lab to do FCC testing pretty regularly. FCC testing has two parts, radiated and conducted emissions. The biggest problem I run into is sometimes finding the right specification because there's so many out there. We're directly involved with the customer. We're there when he fails and says, why do I fail? And then we have to explain it to him and show him ways that he can pass. With more electronic equipment on the market, it's going to, we're going to have more customers, so the company should do well. It'll give us some job security. I think it makes the future EMC pretty good.
The EMC Society is a 4,500-member organization within the 300,000-member Institute of Electrical and Electronics Engineers, the world's largest professional engineering society. The IEEE is a transnational organization of individuals dedicated to improving the understanding of electrical and electronics engineering and its applications to the needs of society. The EMC Society provides common ground for a wide range of people, skills, and disciplines to cope with the growing complexities associated with achieving electromagnetic compatibility. At a recent society gathering, one member succinctly noted its function.
This is where we learn our trade.
The Society conducts its business through sponsoring annual international symposia, publishing technical standards, publishing newsletters and journals, conducting a distinguished lecturers program, supporting technical and standing committees, and administering an awards program to recognize outstanding contributing members. The wide range of disciplines that EMC professionals engage in are reflected in the technical committees the Society sponsors. Active technical committees currently exist for the following disciplines: electromagnetic environments, electromagnetic pulse, spectrum management, non-sinusoidal waves, electromagnetic product safety, EMC management, electromagnetic measurements, and electromagnetic interference control. Members support their society by volunteering on various standing committees where they directly contribute to the work of the society. The committees currently include education, standards, symposia and conferences, technical transactions, newsletters, membership, chapter coordinators, and transnational activities. The work of EMC professionals affects almost every aspect of our day-to-day living. The standards they develop and apply make our lives safer and better. The EMC Society continues to grow in the United States and overseas. The once dominant military aspects of EMC are being replaced by civilian concerns. The need for EMC professionals will expand as the world craves more services from electrical and electronics systems.